Hello students. So today this is chapter 13, motion and time, part 2. So let's solve a problem. The question says that a falcon bird flies with a maximum speed of 320 km per hour. So a falcon bird is there whose maximum speed is 320 km per hour. Now calculate its speed in meter per second. Okay. So what is given? The speed equal to given 320 kilometer per 1 hour. Okay. Now we have to convert this 320 kilometer into meter and 1 hour into second. Okay. This is 1 hour actually. So equal to. Now we know that 1 kilometer is equal to 1000 meter. Okay, so 320 kilometer will be equal to 320 into 1000. So we will write 320 into 1000 meter instead of kilometer. Now we write meter per 1 hour. Now 1 hour is equal to 3600 seconds. So we will write 1 hour equal to here 3600 second. Okay, equal to. So this is indicating divide. Okay, so now we will write 320 into 1000 divided by 3600 meter per second equal to 0 0 0 0 will cancel out, so it will become 3200 and denominator will be 36 meter per second. Now if you calculate this, you will get 88.8 meter per second, and this is your answer. Okay, let's come to the second question. A sprinter means a fast runner, one who runs fast. A sprinter attains a maximum speed of 10 meter per second. What will be his speed in kilometer per hour? Now we need to convert meter per second into kilometer per hour. Okay, so what we are given? We are given speed equal to 10 meter per 1 second equal to. Now this meter will have to convert into kilometer. We know 1 kilometer equal to how much? 1 kilometer equal to 1000 meter. So 10 meter will be 10 by 1000 kilometer. Okay, per 1 second. Now 1 second need to be converted into hour. We know that 1 hour is equal to 3600 second. So what will be 1 second? So 1 second will be 1 by 3600 hour. Okay, we are converting meter into kilometer, that is a smaller unit into a bigger unit. Whenever we are converting a smaller unit to a bigger unit, we need to divide. Okay, similarly second is a smaller unit, we are converting this smaller unit into a bigger unit, that is hour, so we are dividing here. Okay, so 10 by 1000 divided by 1 by 3600 kilometer per hour, we can write like this, equal to 10 by 1000. This divide will become into and it will become reciprocal, so it will be 3600 by 1 kilometer per hour. Okay, now 0 0 cancel, 0 0 cancel, again 0 0 cancel, so what is remain? Only 36 is left behind, so it will be 36 kilometer per hour. Okay, so this is our answer. Okay, now the topic is distance time graph. Okay, here you can see distance of a car at various time is given. So a car's distances are given at various time. At 0 time, 0 distance. Okay, distances are given in kilometer, 0 kilometer, 1 kilometer, 2 kilometer, 3 kilometer, etc. And time is given as minute, that means 0 minute, 1 minute, 2 minute, 3 minute, like that. Now the car travels 0 distance, 0 kilometer distance in 0 minute, 1 kilometer in 1 minute, 2 kilometer in 2 minutes, 3 kilometer in 3 minutes, so like this. Now we have to draw distance time graph for this table. And one more thing, from this table we can clearly observe that the car is going through a uniform motion, because in equal intervals of time the car is traveling equal distances. Therefore the car is said to be in uniform motion. Now we will draw the distance time graph for the car. So first of all, what we have to do, we will draw a horizontal line, a horizontal axis. Okay, and then we will draw one vertical axis. Okay, we will give this name as 0 point. This is x and this is y. Now take at a distance of 1 centimeter. Okay, now at a distance of 1 centimeter, in 1 centimeter interval I have drawn these points. So this is time axis and this is for distance. Now I will number it as 1, 2, 3, 4, 5, 6. Okay. Similarly, we will draw the numbers in this axis also as 1, 2, 3, 4, 5 and 6. We'll name it 1, 2, 3, 4, 5 and 6. Now in 0 minute 0 kilometer. So in 0 minute 0 kilometer. Nothing to do here. In 1 minute 1 kilometer. The car goes 1 kilometer in 1 minute. So in 1 kilometer, so in 1 minute the car goes 1 kilometer. Now extend this 1 minute and 1 kilometer like this. When you extend 1 kilometer and 1 minute, then it will intersect at a point. Okay, so draw a point here like this. Again 2 kilometer in 2 minutes. So this is 2 kilometer, this is 2 kilometer in 2 minutes. So they both intersect at this point. So we draw the points. Similarly, the car goes 3 kilometer in 3 minutes. So here it will intersect. Similarly, in 4 minutes, it will go 4 kilometer. Now you join all the points. You join all the points. So what you obtain? You get a straight line. Therefore, we can say that for uniform motion, if we draw a distance time graph, then we will always get a straight line. Okay, and this is the distance time graph for uniform motion. Now let us draw the distance time graph for the given table. So distance is given and time is given. Okay, now at first we have to draw a horizontal axis and then a vertical axis. This is O, this is X and Y. Now at 1 centimeter interval, at 1 centimeter interval we are giving the points. This is 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour. Here 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, 5 kilometer and 6 kilometer. Okay, this indicates time in hour and this indicates what? Distance in kilometer. Now in 1 hour 1 kilometer, 1 hour 1 kilometer, 1 hour 1 kilometer. So here it intersects, so we draw the point here. In 2 hour 2 kilometer, in 2 hour 2 kilometer, so here it intersects. In 3 hour 4 kilometer distance. In 3 hour, 4 kilometer. So here it intersects. Okay. Then in 4 hour, 6 kilometer. The car travels during 4 hour. How much kilometer? 6 kilometer. That means they intersect at this point. So now if we try to join all the points, we will get a straight line or what? Let's see. Now join all the points. So what do we observe? This is not a straight line. Okay. This is a curved line actually. If it would be a straight line, it would go like this. But this is a curved line. Okay. This is a curved line. So what it indicates? So from this distance time graph, we can say that this is not a uniform motion. If it is uniform motion, then it will be a straight line. But here you can see that this is a curved line. Okay, this is a curved line. So it is not uniform motion, it is non-uniform motion. So the car is traveling at non-uniform motion. Okay, now look at this. Distance are given, time are given. So here a car is there. During 1 hour, the car is at a distance of 2 kilometer. The time is passing by and it is now 2 hour. Still the car is at a distance of 2 kilometer. In 3 hours, in 4 hours, the time is passing by but the car is situated at a single point. The car is at rest. Okay, the car is not in a motion. So in this case, what will be the distance time graph? Let us see. We draw the horizontal axis and then the vertical axis O, X, Y. So this is time and this is distance. Time in hour, distance in kilometer. So now write the values of time. 1 hour, 2 hour, 3 hour, 4 hour, 5 hour. Here also write 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, 5 kilometer, like this. Now in 1 hour, the car is at a distance of 2 kilometer. So in this point, the two intersects. The distance and time intersects at this point. Okay. And then when it is 2 hour, during 2 hour also, the distance is 2 kilometer. So during 2 hour also, the distance is 2 kilometer. In 3 hour also, the distance is 2 kilometer. In 4 hour also, the distance is 2 kilometer only. So now you join all the points, you will get a straight horizontal line. Okay, so whenever a car is at rest, then the distance time graph will be a horizontal line. Okay, so when an object is in uniform motion, then distance time graph will look like this, that is a straight line always. When an object is in non-uniform motion, then the distance time graph will be a curved line, not a straight line. Okay, and when an object is at rest, then the distance time graph will look like this, a horizontal line we will get. Now, advantages of distance time graph. What are the advantages or what are the usefulness of distance time graph? The variation of distance traveled by an object with time can be seen more easily or more clearly. Okay, it means suppose this is a distance time graph and this is another distance time graph. Okay, so from these two distance time graph we can easily say that this represents the motion in uniform. From this distance time graph we can say that the object is moving with uniform motion because you can clearly see a straight line. Whenever you get a straight line in a distance time graph, you can say that it is a uniform motion. That means the object is traveling with equal distances in equal intervals of time. But if you look at this graph, not a straight line. So again from this graph we can clearly say that this object is moving with a non-uniform motion. Okay. Number 2, from distance time graph we can find the distance traveled by an object at any point of time. Okay. Number 3, the speed of an object can be obtained from distance time graph. So these are the 3 advantages of distance time graph. You can read in detail from the page number 216. Okay. In ancient times, there was no clocks, there were no watches. Okay. Now the devices used in ancient times for measuring time. What are the devices that were used in the ancient times for measuring time? They are sundial. Number 2, sand clock. And number 3, water clock. And in your book, a brief note is given about all these devices. So you have a read, and if you get any problem, you ask me. Okay. Then the units of time. I think you know about the units of time. 1 hour equal to 60 minutes, 1 minute equal to 60 seconds, 24 hour 1 day, 30 days means 1 month, and 12 months means 1 year. Okay, they are very simple. And you have to know this 10 years. 10 years is said to be one decade. 100 years is said to be one century. And 1000 years is called one millennium. Okay. Now let us discuss about simple pendulum. Okay, simple pendulum. So this is a simple pendulum where there is a metallic ball which is called bob. Okay, and this metallic ball is suspended by a long thread. Okay, and this is known as a simple pendulum. So what is simple pendulum? Simple pendulum is a metallic ball suspended by a long thread at a fixed point, and this ball can move to and fro like this. If you displace the position, then it can move like this. To and fro motion is seen in simple pendulum. Okay, and this rest position, suppose we will name it A position, A, and this position at which the pendulum is at rest is known as mean position. Okay, this is the mean position. This A is the mean position of the pendulum. Now when you displace the pendulum, if you displace the pendulum, it will move here. Okay, when you displace the pendulum, it will come to this position, and again it will go to this position. Yes, when you displace the pendulum, it will move like this. Okay, and these positions, let us name that B and C. These positions are known as extreme positions. Extreme position. This is also extreme position of the metallic ball. Okay, this to and fro motion of an pendulum is known as oscillation. Now what is one oscillation? When we can say that the pendulum completed one oscillation. Now let's see. When the pendulum moves from the position B to position C and again come back to position B, then that is known as one oscillation. Okay, if this bob of the pendulum moves from B to C, again come back to B, then we can say the pendulum has completed one oscillation. Okay, now during this one oscillation, it required some time. Okay, and that time is known as time period. What is one oscillation? The movement of the bob, this metallic ball, the movement of this metallic ball from position B to C and again coming back to B, that is called one oscillation. And the time taken by this ball to complete this one oscillation is known as time period. So what is time period? Time time taken to complete one oscillation. The time required to complete one oscillation is known as time period. Okay, time period. And now, length of the pendulum. So in this pendulum, what will be the length? The length will be measured from this point of suspension to the center of this ball. Okay, from the point of the suspension to the center of the ball, that is called the length of the pendulum. Okay, and what is amplitude? What is amplitude? The distance of the bob, the distance of this metallic ball from the mean position to the extreme position. So this distance is known as amplitude. Similarly, this distance is called amplitude. The distance from the mean position to the extreme position of the ball is called amplitude. Okay, and one more thing, if you increase the length of the pendulum, then the time taken by the ball to complete one oscillation will also increases. If in this case the time taken by the ball to complete one oscillation is, suppose, 1 second. Now if you increase the length of the pendulum up to here, and then it will oscillate, and then to complete one oscillation the time taken will also increase, and that time the time may be 2 seconds. Okay, so as the length of the pendulum increases, the time period also increases. Now let us solve a problem. A simple pendulum takes 32 seconds to complete 20 oscillations. Then what is the time period of the pendulum? Now we are to find the time period of the pendulum. Now we are given the time taken for 20 oscillation is how much? 32 seconds. Now we are to find out the time period of the pendulum. For that, we have to find the time taken for one oscillation. If we find out the time taken for one oscillation, then it will be our time period. So time taken for one oscillation will be 32 divided by 20 seconds, and it will become 1.6 seconds. So we get that time taken for one oscillation is 1.6 seconds, and that is our time period.